Hi, it's Carly McAvoy. This is part 2 of the practice final for Math 97. These questions from 7 to 14 are mostly about factoring and solve by factoring. The first one says factor by grouping. Whenever you group, you want to make sure that you group the first two and your last two terms together. Sometimes you have to rearrange. We don't have to do that in this class, but in other classes you might need to rearrange to find that factoring. But you want to make sure that your plus sign is here in the middle. If you had a minus sign here, you would put plus minus 7x squared. So be careful about that minus sign if you have one. Then you look at these as groups. What I have in common here, I can take out the y, and I'm left with x squared plus 2. What do I have in common here? I can take out the 7, and I'm left with x squared plus 2. Remember, taking out means dividing, so you're dividing each of these terms by 7, or each of those by y. And now you can see that the binomials match, x squared plus 2, so I can take that out, x squared plus 2, and then I have y plus 7 remaining. I'd always want to look to see if there's a common factor I can take out of this, which there was not out of the whole set. And I also want to look when I get down to here as a second chance to say, can I factor this any further? And neither of those can go any further, so that's as much as you would get. First thing I want to do here is say, is there a common factor in these three terms? There's not. I'm going to factor using the box method. I'm going to put my first term over that first column, which is 3x squared, and my last term over the second column, and down below is my middle term. I want to include my sign because it's important that I get the signs right. So 3x squared can only be 3x times x. And 5 can only be 5 times 1, and since I want to get all the way up to 15, it makes sense that I want to put a 5 here and a 1 there so that I can get, when I multiply across, 15x and 1x. But one of these has to be negative, and if you look down below, we want 14 positive. So the 15 should be positive and the x should be negative, and we never put a negative term in the first column, so it must go here. That we have x times negative 1 is negative x. Now if we add those together, we get the positive 14x, and the answer is on the diagonal, so we get 3x minus 1 and x plus 5 on the other diagonal. When you have the directions to factor completely, that should be a red flag, like, oop, there's probably going to have to take out a common factor or do two kinds of factoring. That factor completely usually means it's going to take more than one step. Here we do have a common factor of 4, so I can remove that from that expression by dividing both terms by 4. Now I have a difference of squares because this is a perfect square and that's a perfect square. So now I can factor that method. X squared breaks down into x times x, and 4 is 2 times 2. And I put 1 plus and 1 minus. It doesn't matter which one you put in which one. And then you can't go any further here, and that's your final answer. Remember, if you take out a common factor, that should be part of your final answer. Now we're going to solve by factoring. We're going to, you can use the box if you need to. This one I really just want to go through it pretty quickly because I think you might be able to see there's really not a lot of choices. P squared is going to be p times p. And 3 is going to have to be 1 times 3. And then we want negative 4. So we want 3 negatives and 1 more negative. Those are both going to have to be negative. And now it makes sense because negative 1 times negative 3 is positive 3. Now to solve this, you're going to set both of those equal to 0. Add 1 to both sides to get p equals 1. And add 3 to both sides to get p equals 3. And those are your two solutions. Notice up here we were just asked to factor, and here we were asked to solve. So solving is something different. We have to actually find out what p equals. Okay, and now we have a similar thing. Can I take a common factor out? No. So I'm just going to have to hope that I can factor this. And if you can't do it by looking at it, you can use the box method. So let's use that, see if we can get somewhere with that. When we do 15w squared, it's either going to be 3 times 5 or 15 times 1. And when we do 2, we're going to do actually negative 2. Really only can do 1 times 2, so that's going to save us some problems. And then sometimes when you're doing the box method, you kind of are guessing and checking. So I'm going to guess something, but I'm going to use pencil in case I guess wrong. But I'm going to guess 3w and 5w. And then I'm going to say 1 times 2. Because I'm trying to get to 7, so I don't think I need to go all the way up to 15. If I multiply straight across, I get 3w, and across here I get 10w. And that would work, because if one of those was negative, I could get negative 7. And so which one should be negative? Well, it should be the 10, so that I have more negatives and end up with a negative 7, which means this is going to be negative. We never put a negative in that first column. So the answer is going to be 5w plus 1. And there are videos on how to do the box method, so if you need to refresh on that, you can go back and check that out from a previous week. And then just to show you though, 3w times 5w is 15w squared. Negative 2 times 1 is negative 2. 3w plus negative 10w is negative 7w. And then we set each of those equal to 0 to solve. We have an equation to the second power. We expect 2 answers. Sometimes we get an answer to repeat, but typically we expect 2 answers there. I'm going to subtract 1 from both sides. I'm going to add 2 to both sides. And then I'm going to divide both sides by 5 to get w is negative 1/5, and divide both sides by 3 to get w is 2/3. So those are the 2 possible solutions for that equation. Now this one, you can see I've got something to the third power. I'm going to be looking for 3 different answers. There's a common factor of x here, so I'll take that out, and I'm left with x squared minus 225. Now maybe you don't have your perfect squares memorized. If not, put it in your calculator and see, is 225 a perfect square? And it turns out to be 15 times 15. So we have x, and then we have x plus 15 and x minus 15. Notice up here I put the minus first and then the plus. It doesn't matter which one goes first, so don't get hung up on that. Now I'm going to have 3 possible answers. X could be 0, x plus 15 could be 0, or x minus 15 could be 0. So if I subtract 15 from both sides, I get negative 15, and if I add 15 to both sides, I get positive 15, and if I was going to type that in, I would say 0, comma, negative 15, positive 15. I think they usually have x equals over here. But we have 3 possible solutions. We shouldn't be surprised because we had x to the third power. Now these last 2, we want to make sure we set everything equal to 0 and then solve. So I'm going to add 8k to both sides. Then I have a common factor of k. So I'm going to take the k out, and that gives me k plus 8. Notice this was to the second power, so I would expect 2 answers. It could be that k is 0, and it could be k plus 8 is 0, and if I subtract 8 from both sides, I get k equals negative 8. So k could be 0 or negative 8, either one. And the last one is the most complicated because first we have to multiply this out. So p times p is p squared, p times negative 1 is negative p, and then I want to move 56 over to the other side. So I distribute that and I move the 56 over. Now I'm ready to factor that. You might see that 56 is 7 times 8, and that makes sense because we want a 1p in the middle. So this is going to be p7 and p8. We just have to think about our signs. We want that to be negative, so 1 negative and 1 positive. We want more negatives, so the greater number should be negative and the lesser number should be positive. And if I set that equal, then I get subtracting 7 from both sides, p is negative 7, and adding 8 to both sides, p is positive 8. So p could be negative 7 or 8. All right, and I will go on to the next part after we take a pause to the next video.